Welcome to this video tutorial from spssvideotutor.com. I'm Jacob Mays, and today I'm going to demonstrate how to perform and interpret a two-way factorial ANOVA. In this demonstration, I will use a data file called class_size.sav. This data set contains fictitious data from 60 respondents. The variables in this data file include gender, classroom size, and math scores. The classroom size variable has three groups or levels: 10 or less, 11 to 19, or 20 or more, and the math scores can range from 0 to 100. Let's begin by examining if there is a significant difference between the two gender groups and the three classroom size groups on math scores. The independent variables are gender and classroom size, and the dependent variable is math scores. We will also explore the possibility of an interaction effect between gender and classroom size. Okay? So the first step is to go to Analyze, and then down to General Linear Model, and then over to Univariate. And then we're going to move math scores into the dependent variables box, and then we're going to move gender and classroom into the fixed factor box. Okay? Then we're going to click on Plots, and we're going to move the variable that has the largest number of groups into the horizontal axis. So in this instance, it's classroom. And then we move gender into the separate lines group, and then we click Add. Click Continue. Then you go to Post Hoc, and then you take your variables that have 3 or more groups and you move them into the Post Hoc Test For box. Okay? And then under Equal Variances Assumed, you select Bonferroni. I'm also going to select Tukey. Now normally you only select one, but I'm selecting Tukey for demonstration purposes only because there are some academics that still use or prefer Tukey. Okay? You click Continue, and then you go under Options, and then we're going to move all three variables into the Display Means For box. So we're going to move gender, classroom, and the gender classroom interaction. And then we're going to select Descriptives, Homogeneity of Variance. Then we click Continue, and then we click OK. So the first box that we see is the Between Subjects Factor table. Okay? This table provides information on the number of factors or groups or levels for each independent variable, how the factors are labeled, and the number of cases in each factor. Okay? So we see that gender has 2 factors. Male is labeled 0, female is labeled 1, and classroom has 3 factors, and you see how they're labeled as well. Okay? The next table is the descriptives table. In the descriptives table, SPSS gives you the number of cases in each group along with the mean scores and standard deviation. Okay? The third table we see is Levene's test of equality of error variances. This displays Levene's test for homogeneity of variance. This tests whether the variances in scores is the same across all groups. All this means is that the absolute difference between the mean and raw scores of each group need to be generally the same. Okay? If the significance value is 0.05 or greater, then the variances are equal and you have not violated the assumption of homogeneity of variance. Okay? If the significance value is less than 0.05, then you have violated the assumption of homogeneity of variance because the variances are not equal, and you probably need to run some type of data transformation in order to fix that. Okay? Now, the fourth table is the test of between subject effects. Okay? This table tells us if there is a significant difference between the groups of our independent variables, and whether there is a significant interaction between your independent variables. Okay? It is important to note that this table does not tell us which groups are different from each other. It simply tells us that differences exist between groups of an independent variable. Okay? The main thing that we are interested in is the column labeled sig, okay, or significance. This is our p-value, and we look to see if the significance value of our variables is less than 0.05. If it's less than 0.05, then that means that there is a significant difference between groups within that variable. All right? So for gender, we see that it's less than 0.05. We also see that it's less than 0.05 for classroom, and we also see that the gender-classroom interaction is significant as well. Okay? So basically what this translates to is that there is a significant difference between males and females in math scores. There is a significant difference between at least 2 of the classroom groups, and it also means for the interaction that there is a significant difference between males and females in at least 1 of the classroom size groups. Okay? Now, in order to determine what these significant differences are, we have to look in different places. So for gender, since it only has 2 groups, we go up to the descriptives table. We see for total males, it's 91.2. Okay? For total females, it's 87.1667. Okay? So that means that males have significantly higher math scores than females. Okay? Now, for the classroom, since there are 3 or more groups, we have to look at the post hoc tests. Okay? Now, if we go down to the post hoc test and look at the multiple comparisons table, we see that this compares the 10 or less classroom size group to the 11 to 19 and 20 or more group. Okay? Anywhere you see an asterisk, that means that there is a significant difference between those 2 groups. So there's a significant difference between the 10 or less group and the 11 or 19 group, and there's a significant difference between the 10 or less group and the 20 or more group on math scores. Same thing here. We compare the 11 to 19 group to the 10 or less and the 20 or more, and we see again that they're all significant. All right, so across all the groups, they're significant, both for the Bonferroni test and Tukey's HSD. All right. Now, in looking at the homogeneous subsets for the Tukey, the way we read this is as follows. Anytime you have numbers within the same set, that means there's no significant difference between those groups. Okay? Anytime you have numbers in different sets, that means that there's a significant difference between the values across sets. So there's a significant difference between the 20 or more group and the 11 or 19 group, and there's a significant difference between the 20 or more group and the 10 or less group, and there's a significant difference between the 11 and 19 and the 20 and more and the 11, 19 and the 10 or less. Now let's say we had the 11 and 19, this number was here. Okay? That means that there would be no significant difference between the 20 or more or the 11 or 19 group, but there would be a significant difference between the 20 or more group and the 10 or less group and the 11 to 19 group and the 10 or less group. Okay, that would only be if this were in the same subset as the 20 or more group, but it's not. All right, now to determine which of these classroom sizes has the highest and lowest scores, we again go back to the descriptives table, and we see that the 10 or less group has significantly higher math scores than both the 11 to 19 and 20 or more. The 11 to 19 has significantly higher math scores than the 20 or more. Okay. Finally, we look at the profile plots to examine the interaction. When the lines are parallel or moving in the same direction, then there is not an interaction. okay? If the lines are not parallel or they diverge, then there is an interaction. So with the 10 or less group, the lines are going in parallel, okay? They're moving in the same direction. However, when you go to the 20 or more group, the lines are diverging, okay? So overall, we see that as class size increases for males, their test scores remain relatively stable. However, for females, as class size increases, their test scores decrease, okay? And this is where our significant interaction is. Now, to confirm this, we will run what is called a simple effects analysis, okay? This breaks down your interaction term so that you can look at the effect of one independent variable across each level of the other independent variable. Now, there's no way to run this using the SPSS dialog boxes, so you have to use syntax, okay? And it's pretty easy to do. So you open up your syntax window, okay? And then, so what you're going to do is you're going to type in these two lines of code. You're going to type in GLM, then you're going to type in your dependent variable, okay, the name of your dependent variable, and then you're going to type in by, and then you're going to type in the names of your independent variables, okay, separated by a space. And then you're going to go to the next line. You're going to type in a forward slash, and then EMMEANS, okay? That's just going to give you a multiple comparisons table. And you write space equals tables, parentheses, your first independent variable, asterisk, your second independent variable, the order doesn't matter, and then you close with a close parentheses, and then you type in compare, and then whatever independent variable you're going to use to compare, in this example we're using gender, you just write parentheses gender, close parentheses, and then period, okay? And then you simply highlight it, run it, and what you do is you go down to the pairwise comparison tables where we compare gender within each of the classroom sizes, and we see here that there's a significant difference between males and females. Now you know how to perform and interpret a two-way factorial analysis of variance in SPSS. If you have any questions, please submit them to jacob@spssvideotutor.com. This has been a video tutorial from spssvideotutor.com. Thank you for watching, and much success with SPSS.